Hey everyone, I'm Brad Myro, a developer advocate with Google Cloud. Today, we'll be discussing data meshes and data lakes, as well as some of the new products available on Google Cloud to help enable these use cases. We'll start by talking about Dataplex, our intelligent data fabric, and then showcase it via a demo in the Cloud Console. We'll then talk about Spark on Google Cloud and how we're doubling down on our Spark capabilities across the platform. Next, we'll talk about Vertex AI Workbench, a single development environment for the entire data science workflow featuring fully managed notebooks and built-in integrations. We'll then show another demo featuring Spark and Vertex AI Workbench, and then we'll conclude with a wrap-up. First up, let's talk about Dataplex, a new product that is generally available as of last month. Dataplex is an intelligent data fabric that unifies your distributed data to help automate data management and power analytics at scale. Let's talk about what that means. Dataplex provides a wide range of features for intelligent data management. These include automatic data discovery, metadata harvesting, and lifecycle management. Additionally, Dataplex provides data quality with built-in AI-driven intelligence. Dataplex provides centralized security and governance of your data through central policy management, monitoring, and auditing for data authorization, retention, and classification. This allows you to provide data access to your end users while ensuring enforcement of proper security policies and best practices. Dataplex at its core is built for distributed data. You can logically unify and organize your data without any data movement or replication. This includes structured, semi-structured, and unstructured data with future support for streaming data. Now, a key use case that Dataplex enables on Google Cloud is a data mesh architecture. It makes it easy to build independent data domains within a data mesh across your organization while still keeping central controls for governing and monitoring your data across domains. You can logically organize data based on how it is used instead of where it is stored. You can set up standardized policies for access control, data quality, classification, and lifecycle management. You can also access data from a variety of tools across Google Cloud Native and open source, allowing you to take advantage of automatic metadata propagation through a unified experience. Now, let's take a look at a detailed view of a data domain within Dataplex. Here, we've configured a sales domain registered as a lake within Dataplex. This domain has several different zones, including raw data, offline sales, and online sales. Automatic data discovery and metadata management occurs across the entire domain, as well as consistent data governance and security policies enforced across different zones. For now, this data lives in either cloud storage or BigQuery across multiple GCP projects, with future support for other databases. You can also access this data via SQL scripts, notebooks, or Apache Spark, which we'll talk more about later. Dataplex also has its own set of built-in notebooks, environments, and tasks for both ad hoc and scheduled workloads. Now, let's take a deeper dive into Dataplex and see the options available to us in the Cloud Console. Okay, so here we are in the Dataplex Cloud Console, and on the left here you can see that we have 5 different tabs, and this tab that we're on here is the Manage tab, and this shows all of the lakes that we have configured with Dataplex. Now, if we want to create a new lake, we can press this Create button. We can provide a name, a region, and then optionally a couple other things such as a display name and a description, some labels, and then a Dataproc Metastore service. So you can choose one that's here, or you can just press Create New Service to create a new one. So let's take a look at this lake that I created earlier. So here we have 2 different zones. And if we want to create a new zone, we can press Add Zone. And then we can provide similar data here. So we can do a display name, an ID, a description, and a type. So there's 2 different types of zones. There's raw zones and curated zones. Raw zones can store data in any format, and curated zones have to be more structured data. So things such as Parquet or CSV or Hive compatible data. And there's some helper text here too that elaborates those in greater detail. So we can also configure discovery settings. Now, by default, Dataplex will discover will run passes on your data and discover it every hour. Now you can change those to one of these, or you can also provide your own custom cron schedule. So on this page, we also have some more information about the lake. So we have some details here, which show us some of the metadata for the lake. We have environments, and these are used to be able to process data processing jobs that are run on data in Dataplex. We have permissions, and this is where you can add or remove principals and roles. And then we have the actions that will detect your data quality and any issues with the data. So let's now look at one of these. So let's look at this zone, the My Project zone. It's a curated zone. So now here we can see that we have 3 different assets. So you have the lake, and within a lake you can have multiple zones, and then zones contain the assets, and those assets represent different data objects. Now to add an asset, we press this Add Assets button. We press Add an Asset, and then we can choose between a BigQuery dataset or a storage bucket. We can provide a name. And then for the bucket, we can choose any of the ones in the current project, but we can also choose from other projects that we have access to. But for this, we'll just pick one of the ones in this project. And then we can decide here if we want all the assets in here, or if we want this asset to inherit the discovery settings from the parent zone, or if we want to press override and provide our own. And then we could press submit. But for this, we'll just go back to the zone page. Now, at each one of those levels, so at the lake level, the zone level, or the asset level, you can change the permissions. So right now, we're at the asset level so that I can change permissions on just any of the data that's within this particular zone. And then I can click into any one of these to then manage the access at that level. I guess that would be the asset level then. So you have details, permission, very similar to what we saw in the previous tab. So now what you'll also notice here is that we have this bad data asset here. And now this has an action required status. And this is where data quality comes into play. So what we can do is we can click on it. We can look at the actions. And we can see that it picked up that this is an invalid data format. And the reason for that is that I populated this with a CSV file that I deliberately tampered with because I wanted it to show that this, or I wanted this to point out that this would be bad data. Okay, so that is Dataplex on the managed side. So let's actually look at some more of these other features here. So we have this secure tab. And what this will do is this lets you actually manage some of the permissions on your data assets and zones and lakes at a higher level. So here you can see all of the different resources. So I can click into one of these. For instance, if I click into this zone here, it'll take me, or it'll actually show me the different permissions that I have available on this. And then you can also do that at the principal level as well. Next, we have process, and here we can create what are called tasks. So these are tasks. These are things that we can schedule for reoccurring data processing jobs. So for instance, to create one of these, we could do create task, and then we see that we have a bunch of different options available to us. So we can do checks for data quality. We can do a PySpark job. We can convert to curated formats from raw formats, and many others here. Next up, we have discover. And so this will actually show all of the assets at a higher level that we have, as well as the lakes and the zones. And so here we have a lake, a table, a zone. So what you can use this for, this will help you discover your data. If you want to see everything that is across all the lakes, you can use this to view the data there. And then last, we have this explore feature, which will let you run SQL queries against the data in the data that you are maintaining in Dataplex, and that will use those environments we mentioned previously. All right, next up, let's talk about Spark on Google Cloud. In the fall, we made an announcement about Spark on Google Cloud, which is us doubling down and making it a first-class citizen on Google Cloud for all of your ETL, data science, and exploration-based workloads. We're accomplishing this across three key pillars. First, an industry's first auto-scaling serverless Spark offering. This empowers our users to shift from managing clusters to focusing on optimizing their workloads. All of the infrastructure provision is taken care of for you. Second, a pervasive Spark experience where we're integrating Spark with our BigQuery, Vertex AI, Composer, and Dataplex services. You'll be able to access Spark more closely to the interfaces and tools you're already working with, as well as utilize a series of open source Spark connectors to access your data. And last, but certainly not least, we are providing flexibility in how you consume Spark. In addition to serverless and our existing Spark on Compute Engine offerings, we announced Spark on Google Kubernetes Engine, or GKE, giving you the ability to standardize on Kubernetes. In summary, one size certainly does not fit all, so we are ensuring that Spark users can utilize it in many different ways. Now, let's talk about serverless Spark and why it's important. Well, Spark developers spend approximately 40% of their time writing code, with the remaining 60% going into planning, provisioning, and managing infrastructure. Spark is an extremely powerful data processing tool, and one of the reasons for this is in the complexity of the number of parameters and knobs that you can tune. With serverless, the auto-scaling and infrastructure configurations are taken care of for you. You can spend your time focusing on the code while letting us handle the rest. Additionally, you only pay for the job duration with no additional infrastructure provisioning costs. You could submit serverless jobs through the API, but as mentioned, we've also incorporated it into some of our other product offerings. So let's go ahead and take a look at those. First up, we have Spark on BigQuery. This gives BigQuery users a unified SQL and Spark experience right from the BigQuery console. We have integrated a PySpark editor into the BigQuery console, powered by serverless Spark. Users can write and submit PySpark code against BigQuery data with the same serverless and auto-scaling experience they're used to with SQL. Next up, Dataplex, which we've just discussed in great detail. Serverless Spark is integrated with Dataplex, letting you run Spark across all of your data in Google Cloud Storage and BigQuery, with the unified security and permissions that Dataplex provides from a single interface. Additionally, you'll have access to serverless collaborative SQL and notebook environments. This can be used across all of your data. Dataplex creates fully managed, user-specific interactive Spark sessions to run your Spark queries and notebooks. Now, in addition to all of these Spark experiences, we also have Dataproc, our fully managed data processing service for open source analytics. Dataproc provides greater flexibility in how you can use Spark via three different consumption options. You can go with managed Dataproc clusters on Compute Engine for fine-grained cost and performance control. You can take advantage of the ease of use of serverless, and you can also run Dataproc on GKE to standardize on Kubernetes-based infrastructure. Now, let's take a look at how Dataproc serverless works. On the left, you can see many of the tools we already discussed. Again, Dataproc serverless is built to utilize many of our existing tooling to make running Spark on GCP as convenient and as easy as possible. In the middle here, we see this concept of a Dataproc compute unit. Dataproc serverless auto-scales via these Dataproc compute units, or DCUs. These provide your jobs with the necessary compute resources and are how costs are calculated. With these, the Spark job starts, auto-scales, and finishes, and all resources are cleaned up automatically. Dataproc serverless integrates with the storage options on Google Cloud, including cloud storage and BigQuery. It also works in your VPC network. You can integrate with the Hive Metastore of your choice, such as Dataproc Metastore, as well as with a persistent history server to store Spark logs. Okay, let's now dive deeper into Vertex AI Workbench for a fully managed notebook experience on Google Cloud. Vertex AI Workbench provides a one-stop surface for doing data science on Google Cloud. It's a Jupyter-based tool that provides a fully managed, scalable, enterprise-ready compute infrastructure environment for your data science needs. You can use it to analyze your data, as well as train and deploy machine learning models, all without needing to worry about the underlying infrastructure. Vertex AI Workbench also provides multi-kernel support for many data science frameworks, including TensorFlow, scikit-learn, XGBoost, and, you guessed it, Spark. You can also access any of the kernels on your Dataproc clusters, and we'll walk through that in the demo. With that, let's head back to the Cloud Console and learn more about how you can use Spark and Vertex AI Workbench.
Okay, so here we have a couple of Dataproc clusters. Now, these are each configured with the Jupyter optional component, which allows you to access Jupyter notebooks on the cluster, as well as having component gateway enabled, which allows you to access web UIs on the cluster. Now, if I wanted to go ahead and create a cluster with the same configuration, I would click Create Cluster. I would then scroll down to Components. Next to Enable Component Gateway, I would check the box. And then next to the Jupyter Notebook, under Optional Components, I would check the box. And then I would press Create. Okay, and now we've switched to our Vertex AI Workbench instance. And we're currently looking at a notebook that is on the Workbench instance itself. Now, this code here is some fairly typical Spark code. What we'll be doing here is pulling some data out of Google Cloud Storage, doing some transformations, and then writing it back out to BigQuery using the open source Spark BigQuery connector. Now, what we're going to do here is show the different kernels we have available to us. So we can click on the kernel menu here. We can, under select kernel, we can select the dropdown. We can see that we have a local PySpark kernel. We also have a local Python kernel. And then we have various other kernels on the other clusters that we have, and those are denoted by the remote tag. So we have a PySpark kernel, or we have our PySpark kernels on the clusters. We have our Python kernels on the clusters, R and Scala as well. So let's go ahead and select this Python 3 kernel. So now we can see that the kernel is what we're currently running on. So what we're going to do now is just execute a couple cells to see that these are running, and it looks like they're running well. So we just do some imports, and then next up we'll create our Spark context. Awesome, and it looked like that worked. So what we're going to do now is actually take this code and submit it to Serverless Spark. Now, the way we're going to do that is using a tool called nbconvert. Now, this is an open source tool that you can have configured on Vertex AI Workbench by default. And what this does is it can take any file or any notebook that you have and convert it into any type of file that you'd like. In our case, we're going to go with Python. So we'll just go ahead and press enter. Awesome, and now we can see on the left-hand side here that a file, okay, great, there's a Python file that was generated from this. And the next thing that we're gonna do is we're gonna take this file and submit it to Serverless Spark. Now, we'll be using the Cloud SDK for this, and with that, we can call the Dataproc API and call batches, and this allows us to submit any job that we want to Serverless Spark, and in this case, we'll be going with the Python file that we just generated. So we can go ahead and press enter, and we'll see that the job was submitted. Okay, so we can go back to the Dataproc Cloud Console, and under Serverless, we can select batches, and then we can see that our job is currently running. Now, Serverless Spark does not write log output while the job is provisioning. So what we can do is we can take a look at a job that ran earlier, and we can check out the log output there. Now, Spark jobs tend to be fairly noisy, but what I've done is I've added some print statements into the workload itself to let me know that the certain stages of the job were successfully run. So we have one here. We also have one here. And we have one at the bottom. So it looks like this is all working as intended. Now, as noted earlier, we can have our log output stored in Google Cloud Storage, or we can set up a history server to maintain our job output.
Whew, we covered a lot today. So with that, let's just briefly wrap up. Here's an example of how you can create an end-to-end data science workflow using tools available on Google Cloud. You can start by using Dataplex to govern and manage your data mesh. You can store your data in BigQuery, run analytics on it using any of the various Spark and Google Cloud offerings, such as Dataproc Serverless, and then train and manage your machine learning models with Vertex AI. Vertex AI Workbench ties this all together as a place to interact with your entire data stack using Jupyter Notebooks. And that's a wrap. Thank you so much for tuning in and enjoy the rest of the sessions.